Okay, we're up. Someone let Kelsey know upstairs that the age of the Linux laptop is here. It just works. So this is CoreOS for cloud providers. The kind of other side of the coin, we've heard a lot the past couple of days about CoreOS for your deployments, for what you're doing as an end user, and how you get up and running with CoreOS, but there's kind of another side of the coin as how it's being integrated into cloud platforms and how you can consume it from cloud platforms. This is Packet, my company, and this is what I do. I'm the VP of Deploy. For the most part, I handle getting things from our developers out into our production stack, our API, our portal, our various code products. And in my copious spare time, I'm the one who gets to handle our CoreOS rollout and the OEM we are building for CoreOS along with that. Disaster management and a few other things as well. Packet itself is a bare metal cloud provider. We are trying to build purpose-built machines for containerized workloads. We offer provisioning of bare metal machines in 5 minutes or less on our own network. And our first config is an app server that we will be rolling out for production in the next, over the course of this month. Enough about that. Those are the slides I was required to have in there. Now let's talk about CoreOS and the implications for hosting and infrastructure providers and the experience we had at Packet building our own OEM and the challenges that provided. When we started out this process, we did not have really the slightest idea what the differences between CoreOS and the more traditional operating systems were. We had a provisioning system that we could use to roll out the other major distros we were doing, but we didn't have a notion as to how this worked in CoreOS land. This is just a quick list of the challenges that we encountered trying to put this together. There's kind of limited documentation from the hosting provider perspective. If you want to offer CoreOS to your clients, how do you do that? It is not necessarily the standard way as your other distributions. There's an unfamiliar OEM model to alter CoreOS images. And by unfamiliar, I mean I would never dream of going to, say, the Ubuntu project and saying, how do I deliver Ubuntu to my clients? And them saying, give us a pull request on GitHub and we'll roll your vendor data back into our image. It's a very unfamiliar model from our perspective to actually have customization and our own images rolled out for us by an operating system. We had very little in-house systemd experience. So far, in the other major distros that we have been working with, is not a requirement, and we didn't have a lot of internal knowledge with it. So we had to build that up as we went, and the notion of doing things through systemd was kind of foreign to us. CoreOS rolls out with the Chromium model with the 9 partitions, and it's how it enables it to do its system updates and the ability to roll back. But that was something that we hadn't really accounted for in how we were rolling out operating systems to our hardware. The network configuration aspect of Cloud Init in CoreOS is a completely custom implementation that we had to add onto for how we were going to consume our network data and roll out our network configuration to our hardware. And we didn't really have any in-house Go experience, so we had to build up our skills in that set as well. At the moment, we are in beta, and CoreOS is installable on Packet by beta users. It will pixie boot the first time, on the first boot only. It consumes the network config from the metadata service. We have bonded 2 by 1 gig interfaces, supports the full user data concepts, and consumes that from either our portal or our API as the user wants. And soon we were going to have it installed with the root partition only with software RAID to disk. That last part where I say soon is where you can really tell we're in beta. I don't recommend rebooting a CoreOS machine on our beta accounts just yet. It won't work. So the point of this talk, and what I really wanted this talk to be, is a discussion between people about what consumers want from a CoreOS hosting provider that is different than the traditional implementations. CoreOS requires a lot of different things from a hosting provider, a lot of things we don't have infrastructure built in for at the moment. But we are building out, and I want to kind of make sure there's some consensus about what people want, and perhaps between the various hosting providers, some standardization about what the best way moving forward on these things is. These are some of the differences I've noticed from CoreOS to more traditional operating systems. It's designed for clustering out of the box. A traditional hosting provider, it's not uncommon for us to get single box orders where people want just a Debian box. And it's also not uncommon for us to do things like year-long contracts for a discount, but that's not exactly the model CoreOS is going on. It's very much designed for cloud providers. People who can bill by the hour when you want to burst and add 10 boxes for a specific traffic pattern. And that's just one notion, but the notion of doing purchase orders for individual machines, doing colo, things along those lines, doesn't really fit with the CoreOS model. User data is a complete requirement. Your Debians, Ubuntus, Red Hats, you're not going to necessarily need a hosting provider to consume user data from an API or a portal and make sure that that gets on your box at provision time. That is generally up to you. But with CoreOS, it's a complete requirement if you want to operate on the speed and scale it's wanting. It's completely ephemeral, and this one, as I was working on it, was a real paradigm shift for me. You don't really need to install anything to disk with CoreOS. As long as you can continue to PXE boot, you're perfectly fine. When you're dealing with virtualization and bare metal, PXE booting can work, but is that really what we want on offering? Do we want choices around that? Do we want people to be able to choose at provision time? Do they want this installed to disk or to continue to PXE boot? Networking in a containerized world can become very complex very quickly. The days where a provider would give you 1 or 2 IP addresses or a small block at the beginning, pretty much going by the wayside. I could see several futures with this one: IPv6 adoption, the assignment of larger blocks of IPs, but how the hosting provider manages those and how the client requests them, I think is a pretty big question that we don't have a lot of great answers around at the moment. The design of CoreOS makes a lot of our traditional provisioning tools not quite as effective as they used to be. We're used to installing a initial image that then can execute kickstart scripts, can install an operating system to disk, can do post-install scripts, with only the root partition being writable in CoreOS. It makes it kind of difficult to do that in a more traditional manner. There are mechanisms in the OEM system with CoreOS using eBuild scripts, using cloud init to execute on these things, but it's not part of our traditional provisioning model. It's not something our other operating systems use. And at the moment I'm seeing, looking through the OEMs that are available in CoreOS, everyone kind of doing this differently. There's nothing wrong with doing it differently, but the question arises, do we want to form some sort of standard around this where providers do things in a similar way, thinking of future compatibility, future versions of CoreOS that may or may not break OEM compatibility in the later releases. These are just a quick list. These are the OEMs I pulled directly from GitHub that exist for CoreOS as it is. If you don't want to download it and roll your own on in some capacity, these are the ones you're going to be going with. And these work for most people and they fit the idea of a cloud architecture at scale, but each one of these does things a little bit differently. But they do have several things in common, things that they're going to have to continue to each do, whether they do it in a standardized fashion or not. The OEM does have its own cloud config file that gets run before the user data cloud config file is run. All of them are going to have to consume metadata of some sort, whether that's JSON or a config drive or something along those lines that lets data get into the operating system before it hits the user space level. Released to the user on a provisioning level, I should say. They all need to take in user data of some capacity. They all need to configure their network in some capacity. They all have some form of e-build script, even if it's just to get the cloud config for the OEM onto the image. And they all have to have some form of system D compatibility. And the question as I was putting together our OEM was, can we take any of these 6 things and make them in some capacity standardized for hosting providers and still meet the individual hosting providers' needs, as they all have different hardware, different virtualization techniques, different ways they're doing things. And this is where I really wanted to open this discussion up as a discussion amongst people in this room of the questions that came out of this. Is there value in standardizing OEM components? Is Cloud Init the best solution for providers to use to customize installs? I think it's a great solution for users. I'm not so sure it's great for a hosting provider to use that to make a standardized install for release to clients. What is the best way to handle channels? They are not really versions. I can't really equate stable CoreOS to Ubuntu 14.04. They're not the same thing, but as far as our user interfaces go in our portals, as far as most of our provisioning systems work, we are treating them as versions. And I'm not convinced that is the best way to handle that. And what is the best way to consume network configuration? Standard DHCP or some other capacity to continue to do that dynamically, or persist that to disk in some capacity. And what I call my $10,000 question that we could probably talk the rest of the session about is, what do people want for storage at all? CoreOS does not require storage. We heard from the gentleman at Google yesterday that the local disk is not a good place to keep your data if you want your data safe. Do you want driveless machines? Do we want to raid the root partition in some sort of software or hardware raid to protect what data does get written to the local disk? Or is it really more important to have easy, cheap network transit to third-party storage systems? I think that's a question the consumer is eventually going to answer for us, but I would love to hear what people think about options thinking along those lines. So with that, I really want to set this up, let's open this up for questions. What do people want to see from a hosting provider? And if there are other hosting providers who have gone down this road, what were the challenges you hit in building your own OEMs and integrating CoreOS into your existing provisioning systems? And with that, yes, sir.
So I have a question about the actual generation of cloud configs and everything. For some providers, they actually provide a direct metadata service. How did you actually handle the capture of a cloud config from a user and presenting it down to an individual host?
Sure. When we started this whole process, we decided to eat our own dog food in a very real way. Our entire platform runs on CoreOS as microservices, and one of those microservices is the packet metadata service, in which there are 2 endpoints. There's the metadata endpoint, which is what we populate with our network config and various other pieces of data we need to provision a machine. And there's a user data endpoint, which is surfaced through our database that collects the user's data and the data for our individual instances. So it's literally locked down on the network so that only you on your machine can consume your metadata and user data, and accessible via curl or via any other method to get data at a URL. Anyone else want to chime in on these particular problems? Yes, sir.
On the versioning of CoreOS, a lot of people on AWS, they don't have the ability to say CoreOS stable with CoreOS Alpha or whatever. It's just essentially a base string that's AMI CoreOS. This could be a little annoying for users to provide the infrastructure to be automatically updated to take care of the down and then start a new one, and they don't have that ability to have essentially that symlink that's going around just an alpha or beta or stable version. It's a little bit annoying. That's some feedback on the versioning thing.
Yes, that's definitely been a concern on a couple of levels. Once we are all the way through the release process with CoreOS, we will have the 3 images that we'll make available on ours. At the moment, we are having to go back and roll all 3 of them individually ourselves so that we keep them pointed at the right place. For that, it was a question internally. We had a lot of, do we provide that? Because you can, in cloud config, just dictate which channel you want, and I could assume as a provider that I provide stable, and if you want alpha, you would put that in your cloud config. The feedback we've gotten is people very much do want alpha and beta channels available. I'm not sure why it bothers me that we are treating channels as versions, but I think it's because they're two different things, and I'm not sure that they really should be treated that way.
I think a good source of inspiration is the Google Compute API. So they have explicit versions, and then they also have kind of these moving pointers.
Well, that's interesting. They actually have a explicit version tag for CoreOS,
Yeah, so there's explicit versions, and then there's also this moving pointer.
and you find that most convenient as a user to be able to.
Yeah,
I think that's what bothered me a little bit about channels was like, if I provision CoreOS alpha today and I run that same script against some provider's API tomorrow, I might not get the same results, and that seems a little off to me, but.
Similarly, if you look in github.com/CoreOS/scripts, in the OEM directory, there are scripts that do that sort of functionality for OpenStack LANs. So you can actually see a scripted example in the real world of like how that actually happens via APIs as well. So there's additional ideas that you can get like of how that happens across the different providers.
So these are going back to these questions that I'd said earlier. I can't see anyone, so if someone has their hand raised, speak up. Has anyone in this room, just a quick show of hands, had to build their own OEM already? That explains a few things about why people are asking questions. Then of these, I think the only one that applies is kind of like how people want network configuration handled. If you're with a provider and you request additional IP addresses, do you want those automatically configured? Do you want them just to be provided and you'll handle the configuration on your end? Where we're kind of aiming to take this, if we can, is a reboot and handle it with our OEM cloud in it to configure the additional IP addresses at that point. Otherwise, I would think you'd have to handle it in your user-provided cloud in it, which breaks a whole lot of automation if you're looking to scale quickly.
Have you done any explorations into like doing IPv6 route advertisements with machines yet?
We do have IP, each of our machines comes with one IPv6, one IPv4, and one private IPv4. So we do have IPv6 working on the individual machines. We haven't had anyone use it yet. We know it works, but most people are not at the point where they're taking advantage of that. Okay, well, I'm around. If people have questions about either what Packet does or have feedback about what you want a telehosting provider you want. At the moment we're in beta, everything, if you apply and are accepted to beta, you are free for the period of beta. Once we do start billing, if you want a $25 credit, feel free to sign up there. And that is what we got here. Yes, sir. Oh, sorry. Yes, sir.
What are you doing to protect the baseboard, the motherboard, firmwares, and other things from the newer type of attacks that are being exposed these days?
You know what? I'm actually going to field that one over to my colleague, Dave. Dave is the one in charge of making sure that our black box remains a black box. Essentially a full factory reset of the box between clients. Yes, sir. You don't need to know Cloud Init to start using our service by any means. Any of the other distros is not required at all. Cloud Init, as far as CoreOS is concerned, is something you're going to want to know just to do any sort of initial customization of your boxes. There's nothing preventing you from spinning up CoreOS without doing any Cloud Init at all, but you'll probably find as you start rolling out CoreOS boxes, you'll want to know something of Cloud Init. Okay, thank you all very much.